Thank you, Kim, for discussing the exciting advances in rotor sails and in ship design. Following, we have a recorded presentation from Constantinos Chaelis, Global Gas Markets and Technology Leader at Lloyd's Register, based in Athens. Due to unexpected work commitments early this week, he couldn't join us, but he has provided a short video of his presentation.
Dear esteemed guests, ladies and gentlemen, good afternoon. My name is Constantinos Chaelis, and I work for Lloyd's Register as the Global Gas Markets and Technology Lead. While due to unforeseen circumstances, I am unable to be physically with you today, I am delighted to be presenting this session and would like to thank CSN, Adonis, and Intergas ANA for this opportunity. Although the title refers to exploring alternative fuels for sustainable shipping, we have come to believe that, especially in the gas sector, commodities will be those driving the market towards a diversified fuel approach. On this note, I will be briefly exploring the LNG and LPG as fuels in the transition portfolio, addressing methane abatement and how LR is driving this through the MAME initiative, while also presenting on the latest ammonia and carbon dioxide prospects. LR has the leading market share in all gas value chains, including LNG, LPG, ammonia, and liquefied CO2 carriers. Our primary focus is echoing the strategic direction in maritime gas supply chains towards the sustainable growth, engaging with technological developments in gas commodity markets, and steering the enhancement of LR service portfolio to the shipping community. We have identified four key pillars when it comes to the LNG as fuel transition portfolio. Lowering of methane emissions through methane abatement technologies and the introduction of methane abatement in Maritime Innovation Initiative, MAMI. Further greening LNG liquefaction by capturing CO2 emissions at source, which combined with methane abatement could lead up to 10% improvement in reducing emissions. Potential bio-LNG blending uptake expected in the next 5-year horizon, and on this point to note, according to CLNG, every 10% of bio-LNG dropping gives another 2 years at least runaway extension in terms of greenhouse gas reduction compliance. And evidently carbon capture, for which we will refer in more detail towards the end of this session. In this example, we evaluate the CII compliance of an LNG carrier to be delivered in 2026, which is based on a similar vessel's operating profile from 2022 data. And given that methane is already accounted for in the regulatory framework, based on a global warming potential GWP 100 approach, that same new building LNGC being delivered in 2026 could risk being out of service by 2040. So measures like methane abatement and onboard carbon capture could extend the asset's operating lifetime, depending always on her trading profile, while also adopting new technologies, as we have seen, like ALS or shaft generators, reliq systems, etc., which might further enhance her ROI. Methane Abatement in Maritime Innovation Initiative, MAMI, is a safety tech accelerator established by LR, led industry initiative aiming to accelerate the adoption of technologies to monitor, measure, and abate methane emissions, tasked with the latest challenge to create a methane measurement protocol to provide a basis for a universally accepted methodology. So far, we have identified over 200 technologies in methane measurement and abatement, and 100 technologies for fugitive emissions, having engaged with over 25 companies to date. Our list of partners counts over 20 members to date, with the latest additions of BP, GTT, and CMA CGM recently announced during Gastech in Houston. The energy pluralism and caliber of the partners involved speaks for itself. On the LPG as fuel transition portfolio, we foresee a similar breakdown of components. It is worth mentioning that based on announced hydrotreating projects, Argus estimates that the bio-LPG market will have grown to over 625,000 tons per year by 2025, an annual growth rate of nearly 30%. Assuming the same rate of increase from 2025 through to 2030, production has the potential to reach 2.2 million tons per year. In addition, the World Liquid Gas Association estimates renewable LPG can potentially satisfy up to 50% of the 2050 global non-chemical LPG demand, whereby near 220 million tons of renewable LPG per year are produced. While reviewing the CII compliance of different age VLGCs, very large gas carriers, and based on 2022 IMO DCS operating profile data, which can be seen on the right-hand side of the slide, clearly an older LPG-fueled VLGC benefits from extended compliance. And when combined with the 30% carbon capture, we witness another at least 5-year life extension approximately, as well as reduced compliance costs, which can be seen on the left-hand side corner of the slide. Last year, during LPG Week in Rome, we presented a techno-economic feasibility, taking a container ship as a case study, um, from which we partnered with a major container ship company. And the results, based on the specific vessel's 2022 IMO DCS data and obviously her operating profile, when it comes to CII performance improvement, considering either LNG or LPG fuels, the results were evident for the next decade with considerable CO2 emissions reduction as well as an extended CII compliance until 2035 and onwards. Ammonia has been identified as the new energy value chain, and the main driver backing up a promising and rising demand lies with the co-firing of coal plants in Japan. Just to note that Japan has over 100 coal power plants to date. More specifically, JERA recently concluded a 3-month trial of co-firing 20% of ammonia with coal at their thermal power station, with the goal to increase the amount to 50% by 2030. Almost 200 harbors worldwide have ammonia terminals that serve the international trade of around 20 million tons of ammonia every year. During 2024, we saw a particular increase in new building orders for very large ammonia carriers, VLACs, as well as MGCs, medium gas carriers. However, we are yet to witness firm ammonia plant production projects, which will be those driving the actual supply and availability of this commodity. In case the market picks up by 2030, we could expect some LPG tonnage being shifted in the ammonia trade and obviously stirring up the fleet dynamics. On the ammonia projects, Exmar and Trafigura have ordered ammonia-fueled medium gas carriers classed with Lloyd's register, currently being built in Korea, which will be the first actual ships running on ammonia fuel. We are also working with Capital Gas on their 4 22,000 cubic meters multi-gas carriers capable of transporting LPG, ammonia, and liquefied CO2, also currently being built in Korea. Peninsula has selected LR for their ammonia bunkering vessel, and we also know that MPA in Singapore wants to be the first ammonia bunkering hub. Last but not least, the next new energy value chain refers to the carbon dioxide. When we manage to combine CO2 shipping with capturing and storage, either sequestration or at facilities, we can achieve what is called closing the carbon cycle loop. We have recently completed a detailed review of over 20 technology providers, either having approvals in principle or being at lower TRL levels, taking also into account CapEx, OpEx aspects, and these results are being discussed with operators either for feasibility studies in retrofit applications or even for new building installations. In this slide, we refer to an indicative list of those companies that were selected and considered by some operators. However, on this note, it is worth mentioning that technologies applicable to date might not be the same in the next 5 years, as we expect significant technological developments. On the other hand, OCCS systems applicability may differ depending on the ship type and the operating profile. Finally, we have developed a carbon value chain focus group consisting of 8 partners aiming to address the challenges and overcome key technical and operational aspects in accelerating CO2 shipping. A progress workshop was also held during Gastech in Houston with quite a diversified attendance of participants. And in the next few months, we will be focusing in work packages 3 and 4, referring to the design and operational aspects for CO2 shipping. I would like to thank you for your time. Although having pre-recorded this session, we are unable to have a Q&A session that would normally follow. Please do feel free to reach out and further discuss any relevant matters. Once again, thank you very much.